Hi students, welcome to Year 10 Science and the physics topic of motion and energy. This is video number 8 on collisions. Now, we're going to have a little bit of a look at the different types of collisions that can occur in situations where the motion of objects can change. Remember, we're trying to make sure that all of the things that we look at are part of our description of objects in motion. And when we look at things colliding, then we can identify two different types of collisions. The first type of collision is called an elastic collision. In an elastic collision, both momentum and kinetic energy are conserved. Now, momentum may be a new term to you, and I will explain that as we go along. Kinetic energy is the energy of moving objects. So anything in motion has kinetic energy, and we looked before at the fact that kinetic energy can be calculated by multiplying the mass and the velocity squared by a half. So kinetic energy is a half mv squared. Now in an inelastic collision, momentum is still conserved, but some of the energy will be transformed. So some of the kinetic energy will be transformed into other forms of energy, which can include heat, it can include light, it can include sound. And if you're thinking at the moment that one of the most common types of collisions is a car accident, then you know that there can be sparks, there can definitely be heat. You often hear the crash, so that's sound energy being released. And so in these situations, these are inelastic collisions. If other forms of energy are being released, then we have an inelastic collision. And in fact, most of the collisions are inelastic collisions that we will encounter in the real world. But either way, momentum is always conserved. So what is momentum? Well, momentum is a property that objects have as a result of their mass and their velocity. So a moving object has momentum. An object that is not moving, that is, its velocity is zero, would have zero momentum. This is the Greek symbol rho, and it is used to denote momentum, and the calculation for momentum is mass times velocity. Not dissimilar to the equation for kinetic energy, but sufficient enough. Work is also an important concept that we need to very quickly look at here. Whether or not you feel like you're doing much work as you watch these videos, work is a physics concept, and it's based on the fact that we can apply a force to a certain object to move it a certain distance or displacement. So any object that moves through a distance and has a force applied in order to move it through that distance has had work done on it. Probably the simplest way of describing this, I will also write work as equal to Fs. S is the symbol for displacement, and that's also one that you may see when you're looking around. Simplest thing is if I have a ball and I lift that ball up against gravity to a certain height, this is a certain height, then I've had to do work on the ball in order to raise it through that distance. As I raise it through that distance, I am increasing its gravitational potential energy. Of course, if I push and push on a wall and the wall does not move, then from a physics point of view, even though I might be dripping with sweat, no work has actually been done on the wall. One of the really nice things about work is work also equals the change in kinetic energy. And this is going to be something that is going to be quite useful for us as we look at examples of balls rising through the air and other types of collisions. So let's have a look at a sporting example, because we will have a separate video that'll look at car crashes and some of the safety devices that deal with some of the types of collisions that we have in cars. But a more common example is a lot of sports. A lot of bat and ball sports obviously involve some sort of an object striking a ball. Even when you're playing football, you have objects coming into contact with the ball. They could be your foot, they could be your hand, they could be your head. And each of these is a type of collision. So we can analyze all of these collisions. One of the important things to start looking at for any motion now is to try and identify the Newton's laws which operate and help us to understand what's happening to the motion. Here's an example of a golf club being used to strike a ball off a tee. The most important thing that's happening is obviously I've got to apply a force in order to swing the club, but right at this point here, you can see a couple of things. You can see a little bit of elastic deformation happening to the ball here. But we've also got a beautiful example of Newton's third law. So the golf club is applying a force to the golf ball. The golf ball right at this point is also applying an equal and opposite force to the golf club. This is equal and opposite forces. So this is the action force and this is the reaction force. Now obviously, because we know that force is equal to ma, this object here, this ball is going to accelerate at a rate of that reaction force divided by the mass of the ball. Now the mass of the ball is going to be much smaller than the mass of the golf club, and in fact I'm probably going to keep swinging the golf club, so I'm going to still be applying that force all the way through. But I stop applying a force to the ball as soon as it leaves contact with the club face. I may continue my follow through. The ball, however, is now solely under the influence of gravity. And so if we're going to describe its motion, it's gravity we must look at. We're going to do some examples of this in class as well. I'll get you to pick an example of a sport where you can identify some of the collisions that are occurring, analyze the forces, and tell me if you can find out what's happening to the changes in velocity as a result of the application of those forces. But that's for another lesson. Thanks for watching.